I'm going to learn how to solve equations involving variables on both sides. My ultimate goal is to find out what 1n equals. So I need to manipulate my equation to make this happen. The first thing I want to do is I want to identify my like terms. So my n's are like terms, but I have a second set of like terms. My terms, my numerical terms. My first goal is to combine each of them separately. So I'm going to take my smallest like term with the variable and move it over to the other side. I always like having my variable on this side and my number on this side. So I'm going to take my 5n and move it towards here. Well, this is a positive 5n. In order to get rid of a positive 5n, I have to subtract 5n. And if I subtract 5n on this side, I have to subtract 5n on this side. So now I'm left with simply just 5 on this side equals 9n minus 5n is 4n minus 7. Now I need to combine my second set of like terms. Well, this is a two-step equation. We've been actually doing this all along. So I have a negative 7. In order to get rid of my negative 7, I need to add 7 to both sides. And remember, whatever I do to one side, I have to do to the other side. I'm left with 4n minus 7 plus 7. So this cancels out, leaving me with just 4n over here is equal to 5 plus 7, which is 12. I can now divide each side by 4. 4 divided by 4 is simply 1n equals 3. Now remember, I always have to check to make sure it's a true statement. So I can plug this back in to my original. 9 times 3 minus 7 is equal to 5 times 3 plus 5. Notice, anytime I plug something in, I'm putting it in parentheses so I know that I plugged it in. Putting it in parentheses helps me when I'm dealing with negative numbers down the road. 9 times 3 is 27. Minus 7 equals 5 times 3, which is 15 plus 5. 27 minus 7 is 20. 15 plus 5 is 20. I have a balanced statement. This works. I have a true statement. It checks. Let's look at another example. I have 7 plus x equals 1 half 4x minus 2. So the first thing I have to do is I have to get rid of this parentheses. This is the distributive property. So I'm going to take this 1 half and distribute it equally amongst everything. I can't just do it to the first. I have to do it to both. So I'm left with 7 plus x on this side is equal to 1 half times 4. Well, 1 half is the same thing as dividing by 2. So I can say, what is half of 4? 2. And 1 half times 2 would be minus 1. Now I'm left with a similar problem like I just worked with. I have variables on both sides that need to be combined, and I have terms on both sides that need to be combined. So I'm going to work with the smallest variable. I want to work with the smallest variable so that I'm left with positive numbers. So I'm going to take this variable and subtract it from this side. Now, remember, when I'm subtracting x, there's actually an imaginary 1 over here because I have 1x. So I'm actually subtracting 1x, which means over here I'm also subtracting 1x. 1 minus 1 cancels out, so I'm left with 0x, leaving me with 7 over here. 2x minus 1x, so I have 2 minus 1. I just look at my coefficients. That gives me 1x minus 1. Now I have a simple two-step equation. If it's easier for you, you can rewrite it as 1x minus 1 equals 7. These are the same thing. I don't change the signs. I don't do anything. I add 1 to each side. 1x equals 8. 1x I can divide from here, or simply say x equals 8. Now I have to check. Let's plug it back into my original. 7 plus 8 equals 1 half times 4 times 8 minus 2 close parentheses. I need to work with this set of data first. I have a parentheses within parentheses, so I have to use my order of operations to do that. 4 times 8 is 32, minus 2 times 1/2 is equal to 7 plus 8 is 15. What is 32 minus 2, I ask myself? That's 30. 1/2 of 30 should equal a number. Well, 1/2 of 30 is the same thing as 30 divided by 2, and I know that's 15. 15 equals 15. My solution checks.